All right, you guys, so you should be watching this after you've already submitted this homework. And this is a calculator active problem because it's problem number 2. And it's on a pretty close year to the year you guys are taking your exam. So 2018 for your response number 2. And it's a velocity problem. So kind of like a position, velocity, acceleration problem. So the first thing that I would do is I would go ahead, because it is calculator active, and store your velocity rule, which they're giving us, in y1. And because you have a fraction, I would definitely do some pretty print action right there. Make sure you're in radians since it has some trig. Watch your decimal places. Make sure this is t squared. So it's 10 times sine of 0.4 t squared all over t squared minus t plus 3. And the stem of the problem is really, really short. It kind of just tells us a particle moves along an x-axis, because remember, they don't always tell us that the position's s of t. A lot of times our particle's moving along an x or y-axis, so we would use x of t for our particle's position. And it's 4 times 0 is less than or equal to t, which is less than or equal to 3.5. So they gave us the time in inequality notation. I went ahead and wrote it in interval notation. And typically on a problem like this, I would write like minutes here, or seconds here, or hours here, but we don't have any units, which is kind of weird. It sometimes like makes your head explode when you have no units. I know it does for Mr. Herney. And then the last part of the stem of the problem just gives us our initial condition. It says the particle is at position x equals -5 at time t equals 0. So I wrote IC for initial condition and wrote it as an ordered pair, but I did label, okay, this is my time. I don't have any units for that time, but here's my time 0, where I'm starting, and this is, because I'm moving along an x-axis, what my x of t function value is at that time of 0. Which, again, I don't have any units. -5 meters, feet, I don't know. Don't add units if they don't give you units, right? That's going to be incorrect. And this is a part A, B, C, D problem. Remember, it's calculator active. So part A says, find the acceleration of the particle at time 3. Well, we have a relationship about acceleration and velocity. So we know acceleration, I'm going to establish that relationship, A of t is equal to the derivative of velocity, v prime of t. And because it's calculator active and we're trying to find the acceleration at time 3, can't we just math 8 it? I mean, show the notation in nice calculus first. Oh, so A of 3, the acceleration at time 3, would equal v prime of 3, but aren't you just going to go to your home screen and do math 8, evaluate at 3 at the rule that you just stored in y1? So you should get approximately -2.118. And because we don't have any units, there's nothing else to say. If we did have units, right, velocity would be some linear measurement with respect to time. So would an acceleration be some linear measurement with respect to time squared? We just don't have any units, so we're just not going to say anything. They didn't ask it for us either. So part B says find the position of the particle at time t equals 3. Oh, so don't we really want to find the position if we're moving along an x-axis, x of 3? Oh, well, if I want to find x of 3, to me this is what makes sense in my world. I want to do that twist on fundamental theorem of calculus. So I want to say the position at a specific time at time 3, this we have to worry about the initial condition on, is going to be our x of 0, wherever our position starts with that time 0, plus the antiderivative from 0 to 3, whatever we accumulate underneath the velocity curve. Right? If velocity is linear with respect to time, and we're doing that for a certain time frame, we're just going to get the regular units back, and we're going to add where we start. So x of 3 should equal -5 plus the antiderivative from 0 to 3 of v of t dt. And then we are going to math 9 that and get -1.760. Because I haven't mentioned this for a while in the videos, some of you on homework, even if it's calculator active and they've defined a rule, you want to like put the rule right here. And I'm not saying you can't put the rule right there, but why? Because if it has more than one term and you don't have the right number of parentheses, or if you're doing anything with subtracting and you don't have the right number of parentheses or distributed negative, it can be written falsely. And if you write it false, it's no points. So if they define the rule for you, just write the rule as they've defined it. Okay? So that makes that part a lot easier. Again, we don't have any given units, but if we knew that this was meters, then this is the meters at time 3. But if we don't have anything, we don't have anything to write down for units. So there's that twist on fundamental theorem of calculus. Remember, if they wanted the position at any time, it would go x of t equals x of 0 plus 0 to t, right, of v of x dx, because this t eventually would probably replace this, so they got to be different letters. We haven't reviewed that whole chain rule part for a long time, and it would probably show up on multiple choice, but I'm going to go off on a little tangent right here. You guys remember if you had something like this, and you had a rule, I'm just making something up, g of x equals, let's say this is negative 2 to 4x squared of f of, let's say f prime of x, no, let's say, yeah, f prime of x dx, I don't know, something like this. And you were taking the derivative of both sides. What do you have? G of x equals, the derivative of the antiderivative goes back to the original function. Let's say that this is f. But because the boundaries are normal, but this is not just a single x, this would probably be t's here, I guess. Wouldn't we be replacing that in, and then we would have to multiply by the derivative of that, which would be 8x. That's that like chain rule part of fundamental theorem of calculus part 1. We haven't like reviewed it for a long time because it doesn't tend to lend itself to free response, but it does show up sometimes on multiple choice. And I don't really know what this year's exam is going to be. There might be a part of a problem that they could throw it in on. So I'm just reminding you a little bit about that. I don't know why it came to me all of a sudden, but it did. So, like I said, a little tangent. All right, continuing. Moving on this velocity problem. So part C. Part C says to evaluate the definite integral from 0 to 3.5 of v of t dt, and evaluate the definite integral from 0 to 3.5 of the absolute value of v of t dt, and interpret the meaning of each integral in context of the problem. So we're like, okay, we know we stored v of t already in y1. This is just a definite integral, so we're just going to math 9 this on our calculator. And we're going to get this answer, which I got 2.844. And then we want to do the absolute value. Remember, you can get absolute value bars on your calculator. You hit alpha y, or alpha in the second thing, alpha window, and it's the first option. And then inside those absolute value bars, which is what's so nice about Pretty Print, you can like substitute in the y2 when you hit alpha trace. And you should get 3.737 to 3 places. And they're not telling us to round any differently, so we're just going to go to the regular 3 places. Okay? So just kind of showing you and reminding you can get those absolute value bars there, which is really nice to like visually see. And when you do that, now it's just a matter of interpreting that. So we're hoping that you remember the difference between these two. Let's start actually with this one, because I'm thinking like this is the one that's going to spark your memory the most. So you guys, isn't the absolute value of v of t going to take our v of t graph, like if we actually looked at it on our calculator, and take anything that's below the x or t axis and flip it to be above? That's what taking the absolute value of the graph does, right? It takes any outputs and makes them flip up. So isn't that like the shortcut way to really calculate total distance? So this represents the total distance. They're going to really be looking for that verbiage of the particle. We don't have any kind of units to say. So again, we don't have feet or meters or any kind of units to say. But it represents the total distance of the particle between or from time t equals 0 to t equals 3.5. And again, because we don't have any particular units to say, we can't put any units on our time. But if you had like seconds, maybe you would write it in closed brackets, because it's from like this exact endpoint to this exact endpoint. From 0 to 3.5 closed brackets seconds or something. But if we don't have anything, I would just list it out in words. Okay, so that would be the answer for the total distance. Well, if I don't absolute value, wouldn't I be doing and sweeping out the area from 0 to 3.5 underneath the velocity graph? Okay, so this would be whatever the time frame would be in time. This would be linear units with respect to time. So the times would cancel and I would just get those linear units, but I might accumulate some stuff below and some stuff above the t or x-axis. So that's not the total distance, isn't that the displacement? So this represents the displacement between time t equals 0 to t equals 3.5. Displacement and total distance do not consider the initial condition.
A couple things. So this actually is the graph of velocity. Okay, so here we've got a portion that's above the x-axis. Here we got a portion below the x-axis. So remember, if velocity is always above the x-axis,
Yeah.
these would be
the
the
same.
same. Okay, and you wouldn't have to take the absolute value. So it's just one thing to kind of keep in mind there.
So maybe kind of graphing that v of t graph might solidify like your answer and be like, oh yeah, that makes sense. Like I'm kind of checking my work. This one should be smaller because I accumulate some negative, and this should be bigger because I'm taking the absolute value of that. Okay? Remember, the long way to do this is a shortcut, easy way to do it, is if you partition it up and you find the spots where you equal 0, so you can take the absolute value of anything below. But then you have to take the absolute value of the whole antiderivative. This is a shortcut way they want you to do once you hit the AP exam. All right, so part D. Ooh, we're almost there, you guys. Part D says, a second particle, oh, what? Now we have a second particle? A second particle moves along, again, the x-axis, with position given by x sub 2, because we're talking about particle 2 of t, and it equals t squared minus t for our same time frame, 0 to 3.5. We're including those, that's why I did brackets. They wrote it in inequality notation. 0 is less than or equal to t, which is less than or equal to 3.5. I wrote it the same way I wrote it up here. So both particles are moving in the same time frame. We just don't know what kind of time it is. At what time t are the two particles moving with the same velocity? So because if you want to know where they're moving with the same velocity, the time, when, right? When, at what time, then we don't want the position rule. We want the velocity rule. So if we think, oh, well, the velocity of our second particle, v sub 2 of t, would just be the derivative of the position. So this is kind of crazy because I have like subscript notation, but then I have like the little tick mark from the prime notation. And really, I need to find this, and it's not like this is hard to find. Take the derivative. It's just a polynomial. So what would this be? 2t minus 1. And I want to know at what times are the velocities the same. So don't I want to take my v of t rule that I stored in y1 from the original particle and set it equal to this velocity sub 2 rule, and I'm going to maybe store my 2t minus 1 in y2 and find where they equal. Find the times where they equal. Graph the two graphs and find where they intersect.
Okay, so I've got it typed in there as y1 and y2. Okay, but if we want to come up with a good window, remember our x value should be from 0 to 3.5. And then I always like to cheat and just use zoom 0, which is zoom fit, because that will give you a good y window. So I want to be careful there because it looks like they come really, really close to kind of touching many times, but it is just going to be that 1 point. So we want to go to intersect. Okay, and we'll say first curve, second curve. And then we'll have you guess, which doesn't really matter because they only intersect at 1 point.
So 1.57054. Cool. That's what I wrote down. But then kind of probably when I wrap it up and give a nice conclusion like in words, I'll round to 3 places because they didn't tell me to do anything else. So I said, therefore, both particles move at the same velocity at time t is approximately 1.570. Remember, correct to 3 places, you have to keep, oh, actually that would round up, huh? 1.571. If that had not been a 5 behind there, you still would want to keep the 0 so that you really have your 3 places. So I kind of just wrote out in red what we were doing. We were trying to find the time, find the input, find the x value where those velocities were equal, and we used the intersect feature instead of the 0 feature. So let's just go through points on this problem, and you'll know how your 9 points are split up. Okay, so part A is 1 point. You had to get the answer correct of negative 2.118 when you did math 8 because you were finding acceleration at time 3. That was finding the derivative of velocity at a certain numerical value. So only 1 and done for part A. Part B was actually 3 points. So you got a point for knowing that you had to do the definite integral. So your boundaries counted from 0 to 3 of the V of t rule so that you could get what you accumulate for the position. But then you had to know to use your initial condition because you have to incorporate the initial condition if you wanted the particle at time 3. So you got a point if you used your initial condition. So kind of like this is okay, x of 0, this is okay, -5. They mean the same thing. You would have had to add that in eventually with your math 9, and then your last point is your answer, which was the -1.760. Part C was 3 points. This is a little mean. You got 1 point for the answers, plural, which means if one of them was wrong, you did not get the answer point. So you had to get the displacement answer of 2.844, and you had to correctly get the total distance answer of 3.737. If you missed that point because one of them was wrong, you still probably could earn your explanation points, but in order to get that point, both answers had to be correct to 3 places. Okay, so you got 2 points for your interpretations. So I'm assuming, it doesn't say it on the rubric, but if this is 2 points, I'm assuming you get kind of like 1 for each. So 1 for your displacement, like understanding and that you said it represents displacement and you had to restate the time from time 0 to time 3.5. And then the other point that you got, total distance of your particle, and that was from the same time. You had to restate your time. So if you don't have your times there, you're going to miss those points. Okay, and then the last part, part D, was 2 points. So you got a point that you knew to set them equal to each other. So you had to take your derivative of the position rule for particle 2 so that you could set that equal to the velocity that you knew way back here for particle 1, and you knew to set them equal to each other. And maybe you don't explicitly say that. I'm hoping that you eventually did. But if you didn't and you got the time where it happens, I'm going to assume that they know that that's what you did on your calculator, since this is a calculator active problem. And then the last point is just for your answer that you said both particles then are moving at the same velocity at the time of 1.571. And since they didn't give us any time frame, that's all we can say, right? So there's another velocity problem, which we hadn't done for a little bit from a pretty previous close year. Any last minute thoughts?
Good.
Okay.